This presentation will be covering three methods of synthesizing esters, but first of all, I'll cover what an ester actually is. So, what is an ester? An ester is a sweet-smelling compound which is often used in common household and cosmetic items such as perfumes and laundry detergent. There are also natural esters in fruit that give them their smell and flavour. For example, peach contains benzoyl acetate, which gives it its taste. Esters are formed when organic acid and an alcohol react together with an acid catalyst. In this presentation, the methods we'll be covering are using carboxylic acid in an alcohol, acid chloride in an alcohol, and acid anhydride in an alcohol.
Esters can be synthesized using carboxylic acids and alcohols. The esterification reaction involves the breaking of a carbon hydroxide bond and the formation of a carbon oxygen bond containing the R group of the alcohol. Esterification can only occur in the presence of an acid or basic catalyst. The catalyst lowers the activation energy for the reaction, while also acting as a drying agent. Some common catalysts used in esterification include phosphoric acid, sulfuric acid, sodium hydroxide, and sodium methoxide. The acid catalysts in this list are preferred, but esterification will also occur with basic catalysts. Esterification can be reversed in a process called hydrolysis. This occurs when a water molecule breaks a carbon-oxygen bond, returning the ester to its constituent molecules of a carboxylic acid and an alcohol. The atom economy of a reaction is dictated by a large proportion of the starting molecule being present in the desired product. The atom economy of an esterification using carboxylic acids and alcohols is relatively high due to only water being produced as a waste product. In addition to this, water being produced means that this form of esterification has no negative impacts for the environment. Using ethanol and propanoic acid as an example, with molecular masses of 46 grams per mole and 74 grams per mole respectively, ethyl propanoate will be formed. Ethyl propanoate has a molecular mass of 102 grams per mole. Substituting these values into an atom economy equation, an economy of 85% is produced. This is a high atom economy for synthesis of esters, showing that esterification using carboxylic acids and esters is an effective method of synthesizing esters.
When using acid anhydrides to form esters, you can react them with either an alcohol or a phenol, although the reaction with phenol occurs at a slower rate. The reactions are slower than the corresponding reactions with using acyl chlorides instead, and the solution also usually needs to be warmed for the reaction to occur at a reasonable rate. The phenol can be reacted with sodium hydroxide prior to the reaction to form the more reactive phenoxide ion or the sodium phenoate salt shown here. This increases the reaction speed as well as changing the secondary product.
Another way to synthesize esters is through the reaction of acid chlorides, also known as acyl chlorides, and alcohols, as seen above. This is an exothermic reaction which produces a byproduct of steamy HCl gas, which can be removed in the presence of pyridine. This reaction is very vigorous and violent, however is less so if you use phenols instead of aliphatic alcohols. Alcohols have an order of reactivity which isn't an exception during this reaction. Primary alcohols react more readily than secondary alcohols, which react more readily than tertiary alcohols. Through using benzoyl chloride, the reaction becomes less violent, just like when using phenols in the place of aliphatic alcohols. With a moderately high atom economy of 67% when producing methyl ethanoate from methanol and ethanol chloride, for example, a big proportion of reactant atoms are present in the product. An advantage of this reaction is that it can be done at room temperature, meaning there will be less damage done to the environment from energy usage. On top of this, a catalyst is not needed. Both of these points mean a decrease in expenses. The byproduct HCl can cause irritation on contact with skin or eyes and is potentially corrosive given high enough levels. HCl emitted into the atmosphere can have seriously negative effects on soil, in particular, increasing its acidity, which in turn can affect growth of many organisms and ecosystems that thrive in the soil. Therefore, it's a disadvantage to use this reaction unless it's in the presence of pyridine.
So, the three main methods we spoke about today are reacting carboxylic acid with alcohol, which produces an ester and a water molecule, reacting acid anhydrides with alcohol or sodium phenolate, which produces an ester and a carboxylate molecule, and reacting acid chloride with alcohol, which produces an ester and hydrogen chloride. The most common method on esterification is using carboxylic acid, as it has a high atom economy and doesn't produce a toxic co-product, unlike using acid chloride, which produces a hydrogen chloride gas, which is toxic for the environment.